Let us do three simple problems in vector addition. The first one is the following. The first vector is given as 4 meters south. So that is the displacement. Of course, the object could have started here and gone all over the place but arrived here. So when you say the displacement is 4 meters south, it just means that the ending point is 4 meters south of the starting point. The other displacement is given as 4 meters east. Now we are asked to find the sum of these two vectors. We know what to do when we want to add the two vectors. In vector addition, you take one of the vectors and slide it until its tail is touching the tip of the other vector. This is also 4 meters long, pointing east, so it's the same displacement vector. And then we join the tail of the first one to the tip of the second one, and that is the vector sum of the two vectors. Now, since this is south and this is east, they are at 90 degrees to each other. This is 4 meters, this is 4 meters. So by Pythagoras theorem, the resultant vector has a magnitude of 4 root 2. That is square root of 4 squared plus 4 squared. You can verify that that is equal to 4 root 2 meters. Now, if I asked you to find the vector sum of these two vectors and you said the answer is 4 root 2, you'd be wrong. Why? Because the answer is a vector. A vector has a magnitude and direction. So you do not say that the sum of the two vectors is 4 root 2. You have to say the magnitude of the sum. The sum is a vector. So the magnitude of the sum is 4 root 2. And you can see by geometry that this is 45 degrees. So in other words, performing one of the displacements first, let's perform the displacement 4 meters south, followed by 4 meters east. The effect is performing a single displacement of 4 root 2 meters at an angle of 45 degrees south of east. So your answer is 4 root 2 meters, 45 degrees south of east. Or you could say 4 root 2 meters at 45 degrees east of south. Or you could simply say, because it's exactly in between south and east, you could say 4 root 2 meters southeast. So you have to give the direction, otherwise you've not told me what the vector sum is. Let's go to the next problem. In this problem, we are given two vectors. One is 4 meters northeast. When they simply say northeast without giving the angle, it means it's exactly between north and east. So it's at 45 degrees to north. So that is the first vector. You're told that the second vector is 4 meters southeast. So that means this vector is exactly at 45 degrees between south and east. So this is vector A and this is vector B. Again, notice they are different vectors, even though they have the same magnitudes. Because they point in different directions, they are different vectors. And the question is, what is A plus B? So we know what to do. We slide one of the vectors until its tail is touching the tip of the first vector. So that is vector B. So this is vector B. And the sum of the two, think of the vectors as displacements. Start at the origin, arrive here. From there, you arrive here. So the net displacement is this vector. Now let's do a little bit of geometry. This is 45 degrees, right? So this is 45 degrees. This is 45 degrees. Remember, B and this B are both in the same direction, so they are parallel. And this is a line that is cutting two parallel lines. So this is 45 degrees. If you look at this triangle consisting of vectors A, B and C, This is 45, this is 45. So this is 90. Since we have a 90-degree triangle, we can apply Pythagoras theorem. So this is 4 meters, that is 4 meters. So C has a magnitude of 4 root 2 meters. So the answer, vector C, is 4 root 2 meters east. You have to give the direction. Let's go to a simple third problem. So the first vector A is 6 meters 30 degrees east of north. What does that mean? That means you draw a vector 6 meters long, you have to go east of north 30 degrees. So you start from north and move 30 degrees. So this vector is this, where this angle is 30 degrees. That is, you start with north and you go east. East of north 30 degrees. The second vector B is given as 6 meters west of south. What does that mean? You start with south and you turn 30 degrees west of south. Let's do that. If I turn 30 degrees west of south, that is also 6 meters, exactly like the previous vector, and you went 30 degrees west of south. So this is 30 degrees. Now if you look at this drawing, you can see that vector A and vector B point in exactly opposite directions. They have the same magnitude. The question is, what is A plus B? So again, what do? We take one of the vectors, vector B, and slide it until its tail is touching the tip of A. So I'm going to slide it and place it at the tip of A, and then this is in yellow color, vector B. See, vector B, I slid it up until its tail is touching the tip of A. Now perform the two displacements. Starting at the origin, get to the tip of A. From the tip of A, get to the tip of B. What happened? You come back to the starting point. So your change in the position is 0. So the sum of A and B in this context is 0. It is not 12 meters. It depends on the directions. So you go 6 meters east of north, and then you come back 6 meters west of south in exactly the opposite direction. You come back to the starting point. The net displacement is 0. When you have a 0 displacement, you do not have to put an arrow on top. You leave it as 0. In the next video, we'll look at vector subtraction.